Originally, I shot a lot of video footage of myself using this at night and demonstrating how it works, and it does work quite well, but unfortunately I lost all that video footage because I accidentally formatted my card one day. Oh well, live and learn. So you're just going to have to bear with me talking about it and looking at it. Anyways, this lens, it is a fly-by-wire type focusing mechanism. In other words, it's not mechanically linked to the focusing ring. Normally, this is something I complain a lot about. I don't really think this is a major issue with this lens, probably because the encoders in this lens are much higher resolution than the ones that I'm typically used to. Me coming from mostly using 4/3 lenses in the past, I think the encoders in those were quite a bit coarser, and so I couldn't always quite find perfect focus. But with this lens, it was very easy to find almost exact focus. I would also consider the lens shade to be an absolute must-have item. I have one for my 50mm f2 macro lens from the old 4/3 days. It keeps the dew off your lens. It also kind of gives you something to strap a dew heater to so that you don't have to be like right on top of the focusing ring. Optical performance matters immensely in astrophotography. Stars are infinite points of light, and they are very hard to render optically. Now let's look at two images here. The one on the right is taken with my 50mm f2. The one on the left was taken with the 45mm f1.8. Exposure-wise, they both work out to being the same thing, even though there were slightly different settings used between the two of them. The lenses were stopped down to f2.8 to eliminate spherical aberrations around the edges of the frame, which both of these lenses have issues with that when used wide open. But at f2.8 it disappears for both lenses. However, you'll notice that the picture on the right, it has significantly more chromatic aberrations. The stars are quite a bit bigger, and this indicates to me that the lens on the left, the 45mm f1.8, is much better at rendering light. The points of light are much more defined and they're much sharper. I'm very impressed with that. There's also significantly less chromatic aberrations on the picture on the left. And one other thing to note, that the picture on the left was taken with a light pollution filter. The picture on the right was not taken with a light pollution filter. I don't want this to turn into a review about the 50mm f2. Both these lenses make good affordable entries into this particular part of astrophotography, and that is the part of astrophotography where you are taking pictures of the smaller constellations. Obviously the larger constellations are not going to fit in this lens, and don't think to yourself, oh, you're not going to get to see any nebulosity with a lens like these. You are going to get to see lots of different nebulosity. And there are a lot of really big things in the sky that you can photograph. Just hop into Solarium and start moving around, and you will just see a lot of different things that can be photographed using either of these lenses. With lenses like these, you'll be able to get to know the sky very well, and you'll see lots of different objects in your pictures, and you'll kind of get a feel for which ones are dim and which ones are bright, and that'll help you to have better expectations when you start getting longer focal length optics and start going after some of the really deeper things in space. Because you don't want to start trying to photograph something and get disappointed because 2 or 3 hours of data isn't enough, because some of these objects do take many hours of data, and then there's other objects that'll be right next to them in the sky that only take an hour or two of data. One more thing that I noticed about the difference between these two lenses is that the 45mm f1.8 was able to resolve 5,000 stars, whereas the 50mm f2 that I have, Deep Sky Stacker, was telling me that only 3,000 stars at the most were visible in the picture. Here's a final wrap up. This is an image that I took. It was just an hour of data. These were 2-minute exposures taken from my Bortle 6 backyard. I was using the multispectra light pollution filter to really eliminate most of the light pollution. These were stacked in Deep Sky Stacker for the Mac and then processed in Photoshop. My final thoughts are that I'm not going to buy this lens, not because it's not a good lens, but actually because I have a budget for a little bit bigger of a lens. I think I'm going to try out the 45mm f1.2 next, and that lens is probably the one that I'm going to buy. But I do recommend this lens to anybody. If you want to just try out astrophotography, this is a really good one to start with.